This is Miss Humbert here, and today we're going to be going over Unit 3, Notes 2, Adding and Subtracting Polynomials. So let's go ahead and let's take a look at what that's going to look like. So first, adding polynomials. So when you add polynomials by combining like terms. And then you want to write your answer in standard form, which means your exponents need to be going from largest to smallest. Okay, so let's go ahead and let's take a look at what that's going to look like. So for number 1, this is like we did on the previous note sheet. We just combined like terms. So our largest exponents here are these x to the third. So we're going to combine those. 4x to the third plus 3x to the third is going to give us 7x to the third. So we're going to cancel those out. Next we have 8x squared minus 5x squared. 8 minus 5 is 3. And then we have x squared. Our next highest exponent is just x. So we have negative 3 plus 5x. So again, we're going to add the coefficients. Then 8 minus 12 is negative 4. So that right there is your final answer in descending order. Okay, so next, let's take a look at number 2. So I noticed that 5x to the 5th is my largest exponent. So I'm going to write that first. Then my next largest exponent is 3x to the third minus 2x to the third. So I'm going to subtract those coefficients and I'm left with 1x to the third, which I can really just write as x to the third. Next I have negative 2x minus 4x. That's going to give me negative 6x. And then 4 plus 5 is going to give me 9. So what I'm going to do is I'm going to have you do these next two on your own. So I just want you to work on combining the like terms. Remember, you're just adding the coefficients. You're not adding the exponents, okay? Now let's take a look at methods of adding and subtracting polynomials. So the first method is horizontally. So that's where you just line up your terms straight across and you combine like terms. That's very similar to what we did on 1 through 4. Next would be the vertical method, which is to line terms up vertically, putting them in columns by like terms. So you notice we have an x squared column, we have an x column, and we have a constant column. That way you can just add down the columns and you make sure you're adding like terms in that method. Okay, well, let's take a look at how some of these will work for adding polynomials. So let's take a look at number 5. I'm going to set this up using the vertical method. So the first one I have is 3x squared minus 4x plus 8. So now I'm going to take this polynomial and I'm going to write it into columns by like terms. So I'm going to put negative 7x squared and put that in my x squared column. I'm going to put 2x and put that in my x column, and I'm going to put negative 5 in my constant column. So now I can go ahead and I can write down the columns. I'm going to add the coefficients and keep the exponents the same. So 3 minus 7 is going to give me a negative 4 and then x squared. Negative 4x plus 2x is going to give me a negative 2x. And 8 minus 5, is going to give you 3. So this right here is your polynomial in standard form. Okay, notice that my exponents are going in descending order. When you're adding and subtracting polynomials, you always want to make sure that your answer goes into standard form. Let's do the same for number 6, again using the vertical method. You can just add across like terms if you want, but using the vertical method really guarantees that you're putting it in the right order. So we're going to do negative 3x squared here. And then I'm going to put 6x in the x column, and I'm going to put negative 3 in the constant column. And then I'm just going to add down the columns. Well, 5x squared minus 3x squared is 2x squared. Negative 3x plus 6x is going to give me 3x. 4 minus 3 is going to give me 1. So again, we have our exponents going in descending order. All of our like terms are combined. So this right here is in standard form. Okay, so let's take a look at number 7. Before we look at number 7, we need to learn about subtracting polynomials. Okay, so subtract each terms by distributing the negative into the term behind it, then combine like terms. So each term behind the subtraction sign will be its opposite, and then subtracting will become addition. So basically what we have to do is distribute in a negative, which you can see they did down here. They distributed in the negative, change the signs of everything in the parenthesis following that negative sign. They distributed in that negative 1. I want you to do that. So many times students try to remember to subtract in their head and they end up making mistakes. It's a lot easier just to change the signs of everything in that parenthesis. Students think it's more work, but it saves you in the long run. So here I see this negative sign right here. So what I'm going to do is I'm going to distribute a -1 into each of those. So then what I end up having is 4g cubed minus 5g. Now it's going to become a positive, and each of those signs are going to shift. I'm going to have a -2g cubed minus 4g. So I changed the signs of everything. Now I'm ready to set up my columns. So I'm going to have 4g cubed minus 5g. Here I have -2g cubed minus 4g. Oops. There we go. Okay, so distributing that subtraction sign changed the signs of everything. 4 minus 2 is 2, so I'm going to write 2 and keep the g cubed the same. -5 minus 4 is -9, and again I'm going to keep that g the same. So my exponents are going in descending order, all of my like terms are combined, so I'm done with number 7. Let's take a look at number 8. So for number 8, I want to change the signs of everything. You could also write it this way if you want, where you just go through and you change the signs of everything. Okay, so then this one would become a negative. So that -7 and that -4 in cube. The longer that second one gets, the harder it will be to remember to change a sign. That's why I suggest you go through and physically change all the signs. So we have I'm going to do 13n cubed, because that's our largest exponent, plus 3n squared plus 5n. So what I did is I put that first one in standard form. And now I'm going to line up the second one to make columns of like terms. So I'm going to put -7n here, and then I'm going to put a -4n cubed here. So what you'll notice is that 3n squared doesn't have anything in its column. That's okay. That means it'll be 3n squared when we get to the bottom of it. So we're going to do 13n cubed plus a -4n cubed. That's going to give us 9n cubed. Now, because this 3n squared doesn't have anything to be added to, we're just going to bring it on down. 5n minus 7n is -2n. So we checked all of our like terms are combined. Our exponents are going in descending order. So we're good for number 8. I want you guys to go ahead and try number 9 on your own. Okay, so you're going to want to distribute in this negative sign by changing the signs of everything. So set up your columns. You will have a column without a number, and that's okay. Let's take a look at number 10. Number 10, standard form, it doesn't really exist for number 10. So I'm just going to kind of make my own version of it. Because we have multiple letters, it's a lot harder to put it into standard form. So I'm just going to put it like that. So that's how I'm going to set up my column. So now what I need to do for this guy, because we're subtracting it, I'm going to go through and I'm going to change the signs of each of those terms. That doesn't mean I just make them all negative, and if they're negative, they're good. No. That means we need to change the signs of everything. So now that I've changed the signs of everything, I'm going to reline out my terms. So now I have -4x squared. That's going to go here. And then I have a positive 2y, that's going to go here, and I have a -6xy, I'm going to put that in the middle. So now I'm ready to add down my columns. So I have 3x squared minus 4x squared. Well, that's going to give me a -x squared. -8xy minus 6xy, again, that's going to get more negative. I'm going to get -14xy. -5y plus 2y is a -3y. So this is our final answer for number 10. Last but not least, let's take a look at number 11. So what we're going to be doing is we're trying to calculate out the total number of elementary school teachers. So the total number of teachers, T, is represented by this T equation. Okay? It consists of two groups, elementary and secondary. Okay? So we have the total is going to be equal to the number of secondary teachers plus the number of elementary school teachers. And the total teachers can be modeled by the following functions. So we have secondary and we have total. So to get elementary school teachers, so the elementary school teachers are equal to the total number of teachers minus the number of secondary teachers. Okay, so that's how I'm going to calculate out the number of elementary school teachers. So now I'm going to take and I'm going to plug in this equation for T, and I'm going to plug in this equation for S. So let's go ahead and do that. So our elementary is going to be equal to 58n plus 2,401. That's for our total, minus our secondary, which is 29n plus 949. So now I'm going to go ahead and I want to change the signs of everything that follows this the negative. Notice it's just in the parenthesis that follows the negative. So 58n minus 29n, that's going to give me 29n, plus 2,401 minus 949. That gives me 1452. And so that represents our elementary school teachers. So that equation right there represents our number of elementary school teachers. So if I gave you that it's 6 years after 1992, you could plug in 6 for n, tell me exactly how many elementary school teachers there are, plug in 6 for n here, tell the total number of teachers, 6 for n here, you get the number of secondary teachers. So that concludes your note video today. Please make sure you take that Schoology quiz before you start the practice sheet. Thanks for listening.